We are Nest, the Near East Side team from Ball State University, given the responsibility to design an urban single-family home in the neighborhood of Inglewood on the east side of Indianapolis. Our team is comprised of 9 undergraduate architecture students with various concentrations in construction management and historic preservation. Our design, Project Indy Infill Reimagined, is an innovative and creative approach to an infill home for an empty lot on Oxford Street. 225 North Oxford Street was the site chosen for the urban single-family home because of its array of possibilities. The site currently sits empty between 2 existing homes. Oxford Street has immediate access to East Washington Street, providing bus routes and necessities nearby. The parcel sits only 1 block from the local library branch and multiple community churches. Oxford Street is a residential street with large, matured trees and a community garden. Our site is an infill lot which will help repair the fabric of an intact residential street. With multiple vacant lots on Washington Street, there is great potential for future neighborhood development. An urban single-family home is the perfect solution for this empty lot. However, it comes with its constraints as well. We chose to design a 20-foot wide home for good solar access and separation from the existing houses. The second biggest hurdle is the overall square footage of the site. At 6,400 square feet, we needed to justify the use of this sized lot. We look to implement an accessory dwelling unit on the site to help mitigate the abundance of space. Our first project goal is to create an adaptable home to age in place that is affordable, comfortable, and appealing to our target market. Our second project goal is to create a water collection system that utilizes on-site water and provides a filtered water source for the future residents. Our third project goal is to provide passive solutions through placement and orientation via windows and skylights for comfort, ventilation, and lighting. As for site design, we plan to implement permeable concrete pavers and concrete paving for accessibility around the entire site without the use of stairs. The wood pergola, with wisteria growing throughout, creates a path from the house to the ADU, making the backyard a potential space to be shared among residents. The wood shading walls provide privacy on the front porch and back patio. We also designed a garden and elevated planters for easy accessibility to homegrown fruits and vegetables. The on-site water will be collected and stored in water barrels along the site for irrigation purposes.
For our layout, we wanted to provide our clients, the elderly, with a floor plan that provides them with a sense of privacy, security, and most importantly, allow them to feel comfortable in every space of their home. The floor plan was based on an 8-foot by 20-foot grid system, with the reason being our CLT panels come in 8-foot widths. On the first floor, we have a very open kitchen and living space. We did this to allow for a more sociable environment, with it being what we would assume the most occupied spaces. On top of this idea, we created a double height space in the living room that connects the living space on the first floor with the multi-use space on the second floor. The master bedroom is also located on the first floor while being connected to the full bath, as it would be more convenient for our client to complete their everyday needs. Other spaces would include a bedroom on the second floor with a full bath, a centralized stairway and utility room, and a hallway on the first floor that connects to all the interior spaces.
The interior of the home was thoughtfully designed and considers the target market of an aging-in-place population. The exterior walls are left unfinished to expose the CLT construction and bring a natural wood texture throughout the home. Cork flooring was chosen to complement this wood texture. The cork tiles are made of 100% recycled materials and provide a soft and warm feel to the floors that other flooring types would not have. Butcher block counters were chosen for the kitchen to continue this wood texture. These counters have a durable finish and are just as resilient as any other type of counter. Throughout the home, neutral colors were chosen to complement the colors of the CLT panels as well as to complement any furniture that an occupant may bring into their home.
The heating and cooling loads were calculated using VOPT. After a workshop with the ASHRAE Central Indiana chapter to evaluate HVAC system decisions, a ductless variable refrigerant flow, or VRF, system was chosen in order to provide both heating and cooling in one efficient, highly adaptable unified system. The system has been sized to account for the peak heating and cooling days and is comprised of multiple zones, one in the living space, one in each bedroom, one on the second floor living area, and a separate system for the accessory dwelling unit. An energy recovery ventilator, or ERV, was chosen for our climate because it's humid and the ERV can deal with latent loads, as well as providing fresh air and exhausting stale air through a heat exchanger. The system is equipped with 2 fans, one that draws fresh air into the home and one that pulls stale air out. This ERV, which is a dedicated balanced ventilation system, is necessary because the heating and cooling system does not bring in supply air from outside. The ERV also delivers dehumidified air to the spaces so that the VRF only has to handle the sensible loads in the house. An electric heat pump water heater system typically has a higher initial cost than conventional storage water heaters. However, they have lower operating costs, which can offset their higher purchase and installation prices. Heat pump water heaters use electricity to move heat from one place to another instead of generating heat with burning fuel. Therefore, they could be 2 to 3 times more energy efficient than conventional electric resistance water heaters. To move the heat, heat pumps work like a refrigerator in reverse. It's best to locate a water heater close to sinks, showers, and appliances where the hot water will be used. A shorter hot water pipe will save energy and water. The water heater will be located in the wet core of the home near the kitchen and restrooms.
One important benefit of rain barrels is that they reduce the amount of runoff from our roofs. Runoff is a huge problem in urban and suburban areas, polluting our waterways with fertilizers, pesticides, and other contaminants. Runoff also overwhelms stormwater systems, especially when we have large rain events like flash floods. Harvesting rainwater can be a money saver, ultimately reducing the water bill. A typical gardener can save as much as 1,300 gallons of water during the growing season. Landscape watering typically accounts for up to 40% of a homeowner's water use during the summer. Collected rainwater can be used for irrigation and exterior cleaning. Our house is designed to put energy conservation first, from framing to finishing. Cross-laminated timber, or CLT construction, with continuous insulation is used in our home. Our home incorporates triple-pane windows, which are up to 25% more efficient than double-pane windows. The roof section was similarly designed to provide excellent insulation and air tightness without the opportunities for moisture to collect.
To begin design, we first have to analyze the market data to fully understand who we are designing for. For instance, the average household income is significantly lower than the rest of the United States, while the poverty rate is significantly higher. Fortunately, there is much better value in rentals in the Indianapolis area. Because of this, we were able to design so that the future homeowner has the opportunity at passive income. We focused our target market towards those looking to age in place and creating affordable housing for the people of the Englewood neighborhood. Englewood CDC, one of our community partners, also recommended affordable housing, but is looking for replicability of infill housing. As we can see, 39% of Englewood's lots are vacant. By creating a state-of-the-art design, we can establish a model for future development while maintaining our net zero goals. In order to keep costs as minimal as possible, we have to evaluate both upfront and long-term costs. For the construction of this home, we chose to use CLT panels. The cost of these panels is essentially equal to the cost of typical stud-framed homes. The main difference comes from the time frame for installation, which can be essentially cut in half and saves on labor. Another way to save money in the long run is by exceeding the Passive House Institute 2021 Plus prescriptive pathway standards. The Passive House Institute standards far exceed the Zero Energy Home Ready and 2015 IECC standards. Because of this, and the fact that we installed a photovoltaic system, the homeowner will be able to recoup nearly $2,500 each year in energy savings. The best way for us to determine a target price range is to determine what the monthly payment should be for the homeowner. By taking the average Englewood resident's income and using 1/3 for its maximum budget for the housing, we determine that the monthly payment must remain under $1,400 per month. By utilizing a community development grant, the yearly energy savings, Indiana's property tax exemption for renewable energy, and the $520 a month of rental income, the monthly payment will be only $863. This monthly payment would be affordable for our target market, especially considering the lack of monthly utility costs.
For this urban single-family home, cross-laminated timber panels are used for the structure of the building, including the walls, floors, and roof. Initially, this was chosen because of its underutilization in the region, its durability and resilience, and its ability to span great lengths. Later, the realization was made that CLT panels and other wood products have a massively positive influence on the embodied environmental impact of a building. Wood actually acts as a carbon sequester and has a positive impact on global warming potential because of its ability to capture and store carbon dioxide within itself. Because of the use of CLT panels for this home structure, 110 metric tons of carbon dioxide will be stored in the wood and 43 metric tons of greenhouse gas emissions will be avoided.
We use CLT panels for the construction of our single-family home. CLT offers many benefits such as design flexibility, fast installation to cut down on labor cost, thermal performance, energy efficiency, and many others. I studied the detail of the connection systems on CLT panels and more specifically the connection of the floor panel to floor panel, which is shown in diagram 1. Here we used a fully threaded timber screw and a partially threaded timber screw to resist any possible shear. In diagram 2, it shows the wall to concrete slab connection. Here we used a steel plate on the outside of the house and a L-shaped bracket on the inside and fastened these two brackets with anchor bolts and masonry screws. In diagram 3 shows how the second floor connects to the wall. Cutting an insert into the CLT wall allows for the builders to use a metal C-bracket that is hidden and to hold the floor tight to the wall. I was also on the exterior material selection team and we chose to use steel siding and a metal roof. There are so many good qualities to steel siding in terms of appearance, protection, and longevity. We chose to use both a board and batten siding and a Vesta plank siding, and a high seam T-panel style for metal roof. This material resists moisture, rust if the steel is fused with a PVC coating, in which the manufacturing we chose to use does. It also resists sleet and others that are listed on the slide.
Because we designed the house to comply with the FIAS 2021 prescriptive pathway, the house has much more insulation than a typical house, which has resulted in an increase in the global warming potential. To combat this, we used a wood fiberboard insulation which requires only a third of the energy to be produced than that of foam insulations that might be found in other highly insulated buildings. We also increased the amount of wood we used in the house for its carbon sequestration properties. The use of CLT and a dense amount of insulation has made the house have a very airtight and high-performing building envelope. This essentially lowered the energy usage of the house, allowing for all energy to be produced on site and the elimination of over 27,000 pounds of carbon dioxide per year that would come from the source energy production.
The solar array utilizes a MPPT inverter to achieve high efficiency. Therefore, even in shaded conditions or snow, some panels can still continue to operate and collect power for the house. By then providing energy-efficient appliances, heating, and cooling systems, the house will require less electricity to be needed. Passive systems such as lighting, heating, cooling, and ventilation utilizes architectural features to further reduce mechanical dependence with the use of skylights, stacked ventilation, and south-facing windows. The layout separates the floor plan between living and mechanical space. This way, systems within the house can be placed in a way that achieves maximum productivity with minimum wasted effort or expense. Mechanical equipment is placed within the core of the building and storage is placed along the northern wall. This mechanical core is a central point that also holds the stairs, bathroom, and laundry that allows for outside entry for easy access to the mechanical system. Mechanical systems branch out from the core, saving costs from expansive connections to equipment.
This residence is designed to be a moderate smart home to allow an affordable, accessible home system for any occupant within the residence. This will increase the convenience factor within the home while also decreasing necessary maintenance within the future. Smart lamps will be the primary lighting system as they are an affordable option that can be purchased at any time. We also recommend that the occupant uses LED light bulbs since they have the longest lifespan and are the most energy efficient. The thermostat and fire detector will be Wi-Fi enabled to allow the occupant to receive notifications on their phone about the temperatures within the residence and to protect their home from fire while they are away. This, along with the Ring doorbell, will allow the residents to have the ability to check on their home even when they are not at home. Recommend the occupant to install these ENERGY STAR certified appliances in their residence. Having these ENERGY STAR appliances will not only help the occupant to save money on their energy bill, but also the listed appliances come with at least a 3-year manufacturing warranty, which will reduce cost and stress of repairs in the future. The selected front-load washer and dryer is a great selection for older occupants when installed on platforms, as these will reduce the need to bend over and reduce the strain on their backs when changing heavier loads such as blankets. This will help to provide comfort and safety to the occupants residing within the home. Although our residence is not completely ADA compliant, we made sure to focus on architectural aspects to improve the quality of life of senior occupants during our design process. This includes, but is not limited to, all doors on the first floor having a 36-inch wide doorway, the hallway being 36 inches wide, designing a bedroom on the first floor to reduce the need for stairs in their daily life, light switches being installed 36 inches off the ground, and the use of low maintenance materials. These simple design strategies allow seniors to have a higher chance of staying in their own residence rather than being placed in a care facility.
For the ventilation of the home, an energy recovery ventilator, or ERV, was chosen. These systems provide good ventilation and moisture control while remaining efficient and quiet during operation. This unit chosen is the Zehnder Comfo Air 160. Zehnder is a very good company to choose for ERV systems. This unit is 88% efficient and is able to provide the airflow needed in a home of this size. Additionally, bathroom ventilation fans and kitchen range hoods are used to properly control the additional moisture in these rooms. These units exhaust directly to the outside without passing through the ERV so that it doesn't damage the unit over time. Because the ERV system doesn't provide heating and cooling, a separate system is required to meet those needs. For this, we chose a variable refrigerant flow system, or VRF. VRFs can control multiple zones within a home individually and can even provide heating to one space while providing cooling to another. This type of system provides the best control for occupants and can greatly improve their comfort in the home. The system chosen is made up of Bryant ductless VRF indoor and outdoor units. The indoor units that were chosen are attractive and not visually disruptive to the occupants. Additionally, the controls are easy to use and can be integrated with other smart home technology that is used in the home.
EUI, or energy use intensity, is an indicator of energy efficiency of a building's design and/or operations. EUI is expressed as energy per square foot per year. Using the BOP to minimal values that would meet the IECC 2015 ZERH requirements, we achieved an EUI of 40 kBTU per square foot per year. We decided that it was necessary for the home to comply with the requirements for the Passive House Institute US 2021 Plus prescriptive pathway, which is the gold standard in design for passive building certification in North America. Using this pathway, the EUI was lowered to 26 kBTU per square foot per year without a PV system and an EUI of -1 kBTU per square foot per year with a roof-mounted PV system. After working with local solar energy provider Jefferson Electric from Indianapolis, Indiana, we were able to specify a photovoltaic module that would be the perfect fit for this application, the Panasonic Evervolt 370-watt solar module. According to the PV watts calculator provided by NREL, the system will provide approximately 13,000 kilowatt hours per year, or 45 MMBTUs per year. With the overall energy use of the building being 41.2 MMBTU per year, it's producing more energy than it uses in the span of the year, meaning that the building is meeting the net zero requirements. Additionally, space has been left on the roof for either expansion of the PV system or the addition of a solar water heating system.
The urban single-family home at 225 North Oxford Street is not like any other home. It is better. Our vision was to create a durable and resistant infill home that allows a couple to begin their life together, start a family, raise and nurture that family, and remain independent when the children are grown and the couple has aged. Our project layout and design is intended to provide an efficient and affordable home for the lower income population in the surrounding Inglewood neighborhood. This infill property offers strength and simplicity, as well as a lighter environmental footprint.